Hi all, today we are going to discuss induction type instruments. In all induction meters we have two fluxes which are produced by two different alternating currents on a metallic disc. Due to alternating fluxes, there is an induced EMF. The EMF produced at one point, as shown in the figure given in the top of the slide, interacts with the alternating current of the other side, resulting in the production of torque. Similarly, the EMF produced at the point 2 interacts with the alternating current at point 1. Okay, this is the point 1, this is the point 2. Okay, point 2 1 resulting the, hence due to these two torques which are in different direction, the metallic disc moves. This is the metallic discs. Okay, moves. This is the basic principle of working of an induction type in induction type meters. Now let us derive the mathematical expression for deflecting torque. Let us take flux produced at point 1b equal to F1 and the flux and the point 2b equal to F2. So F2. Now the instantaneous value of these two flux can be written as, the flux 1 and flux 2 can be written as F1 is equal to F m1 sin omega t. F2 is equal to F m2 sin omega t minus b. Okay, where F m1 and F m2 are respectively the maximum values of fluxes F1 and F2. B is the phase difference between two fluxes. We can also write the expression for induced EMFs at point 1 b 1 can be E1 is equal to minus d F1 by dt and E2 is equal to minus d F2 divided by dt. At point 2, thus we have the expression for eddy currents at point 1 is I1 equal to EA divided by Z equal to K into small f into F1, where K is the some constant and F is the frequency, small f is the frequency. Let us draw the phasor diagram clearly showing in F1, F2, E1, E2. So these values are, we have I1 and I2. From the phasor diagram, it is clear that I1 and I2 are respectively lagging behind E1 and E2 by angle of A. Okay, this is F1, this is F2, this is E1, this is E2. E1 and E2 and lagging by the current I1 and I2. This shown in the this phasor diagram. This is the 90-degree phase angle. Okay, F2 to E2, and B is the happening in F1 and F2. This is the phase difference between F1 and F2 is the B. So this is the A angle shown in the current lagging. Okay. Next, the angle between F1 and F2 is B. So see here, the angle between F1 and F2 is B. So B, from the phasor diagram, the angle between F2 and I1 is 90 plus B plus A. So now see the phasor diagram, B plus I2 to F1 is B plus 90 plus A. So that's why we are given 90 plus B plus A. Thus we write the expression for deflecting torque is TD1, deflection torque 1. That's why TD1 equal to K into F2 into I1 into cos 90 minus B plus A. This deflection torque 1 is equal to K into F1 into F2 into F divided by Z cos 90 minus B plus A. Similarly, the expression for TD2 is TD2 equal to K into F1 and F2 into F divided by Z cos 90 plus A plus B. See here, for D1 this is 90 minus B plus A. For D2 this is 90 plus A plus B. Okay, the total torque is TD1 minus TD2 on substituting the value of TD1 and TD2 and simplifying the expression, we get TD1 minus TD2 is equal to, we get K into F1 and F2 into F divided by Z sin B and cos A. Sin of A cos of sin of B cos of A, which is known as the general expression for the deflecting torque in the induction type meters. Now there are two type of induction meters and there are written as follows: single phase induction type energy meter and three phase induction type energy meter. There are two types of energy meters are there. So induction type instruments, this is the circuit diagram for the single phase induction type energy meter working. Here this is the disc, aluminum disc, this is the current coil, this is the aluminum disc, this is the pressure coil, this is the shielding banded. So here we have assumed that the pressure coil is highly inductive in nature and consists of very large number of turns. The current flow in the pressure coil is IP, which lags behind the voltage by an angle of 90 degree. Is current produces flux F. F is divided into two parts, Fg and Fp. See here, this is Fg and Fp. So Fg, which moves on the small reluctance part across the side gaps, and Fp, it is there responsible for the production of driving torque in the aluminum disc. It moves from high reluctance path and is in phase with the current in the pressure coil. Fv is alternating in nature and thus EMF EP and current IP. So see here, this is the single phase induction type energy meter working. Next, the load current, which is shown in the above diagram, is flowing through the current coil, produces flux in the aluminum disc, and due to this alternating flux there are the metallic the disc, an eddy current is produced which interacts with the flux Fe, which results in production of torque. Yes, we have two poles, thus two torques are produced which are opposite to each other. Hence, from the theory of induction meter, that the net torque is the difference of the two torques. Okay, net torque is difference of the two torques, torque D1 and torque D2, deflection torque. Next, induction type instrument, single phase induction type energy meter construction. So in this construction we will see the driving system. The driving system consists of two electromagnets on which pressure coil and current coils are wounded, as shown in above diagram in the right corner of the slide. The coil which consists of load current is called current coil, while coil which is in parallel with the supply voltage, the voltage across the coil is same as the supply voltage, is called pressure coil. Shading bands are wounded on as shown in above in the diagram, so as to make angle between the flux and the applied voltage equal to 90 degree. So next we will see the moving system. The moving system, in order to reduce the friction to greater extent, floating shaft energy meter is used. The friction is reduced to greater extent because the rotating disc, which is made up of very light material like aluminum, is not in the contact with any of the surface. It floats in the air. One question must be arise in our mind, is that how the aluminum disc float in the air. To answer this question, we need to see the construction details of this special disc. Actually, it consists of small magnets on both upper and lower surfaces. The upper magnetic is attracted to an electromagnet in upper bearing, while the lower surface magnet also attracts towards the lower bearing magnet. Hence, due to these opposite forces, the light rotating aluminum disc floats. Okay. Next we will see the braking system and counting system. So the braking system, a permanent magnet, is used to produce braking torque in single phase induction energy meters which are positioned near the corner of the aluminum disc. Next, counting system. Numbers marked on meters are proportional to the revolutions made by the aluminum disc. The main function of this system is to record the number of revolutions made by the aluminum disc. So this is the induction type 3-phase energy meter. This and all we will discuss in the unit 2.